All right, well, welcome to ElmLive for November 27th, 2016. This month, I have been streaming pretty much every day for the month of November for the Codevember challenge to do a small little creative coding project every day. So we will be doing another project for that today. And there are just a few more days left in November, so I'll be continuing that in the few days to come. And then in December, we'll be switching back to our regular, longer projects for ElmLive on our regular Sunday streams. Before we jump into the code today, I wanted to share a little bit about some of the things I have been learning about in politics in the last week or so. So this was the most interesting one, was learning a bit about how to communicate with your elected representatives in the United States. And again, I'll stick all of these links in the chat description and in the YouTube description as well. So this is an interesting Twitter thread from a woman who worked in Congress for several years and goes through a lot of details about how you can make an impact and get information to and from your elected representatives. The most notable thing with that is to actually take the time to call your representatives on the phone, which leads me to the second thing I wanted to share. This woman, Maria Chatfield, built over the weekend a little project that she shared online, which lets you quickly find your representatives and call them. There's actually another site that already exists called whoismyrepresentative.com, which is similar. And Marie wrote a nice little Medium post describing some of the shortcomings she found with that site and why she decided to build her own version of it and where she got the open data that powers the site. And it's a nice little site. It's also responsive, works nicely on mobile phones as well. And let's see, just to show as an example, you can put in your address too optionally, but you can also just put in your zip code. You get the phone number, Twitter accounts, and this interesting site called GovTrack, which shows some of the voting information, or like what different representatives have voted on recent bills and if they've sponsored bills, and some other interesting information and data visualization. So if you are interested in getting more involved in politics, I think those are a great place to start, and I would encourage you this week to find an issue that you are concerned about and find the phone numbers of your representatives, give them a call, and basically just express in a sentence or two what your concern is, and the staffers that answer your call will take a note of that and tally it up, and that's one of the simplest ways to start getting more involved, at least from what I've learned so far. All right, let me save this tab, and I'll save these on my other screen so I can share the links later. Hey everyone, welcome to the chat. Albernacker, my name is Aaron, by the way. I guess I don't usually say that in my intro. Alright, so for today, here's my idea for today. I want to use SVG, and I want to use mouse interactions, and make a little app that'll have like some disks lying flat on a surface, and as you move the mouse around, you can kind of flip those over and have those be animated and kind of have an interactive animation as well. So that's what I want to try doing for today. We'll be using Elm 0.18 again. And let's start with our main.elm. And I guess we also need to start by running elmmake to install our base packages. And we also need to install elmlang SVG. Okay, and then we can write our basic main.elm and get something up. So the first thing I want to get up is just a circle on the screen rendered with SVG. So we will import SVG. We're also going to import HTML for the program. Our main is going to be a program, which will take no flags. We're going to have a model type and a message type, which I guess we should define. And we'll fill in the rest of this in a minute. So let's think a little bit about what our model is going to be. So let's see. My plan here, and I'm not sure if I brought up this cool little Elm geometry interactive thing to try to draw some nicer diagrams than I usually can just explain verbally. So my idea was that we are going to have, let's see, we're going to have a circle, and we'll be looking down on it from the top. And we'll imagine that that is like a coin sitting flat on a desk. And then, for instance, as I move the mouse, like the mouse is going to be like a finger underneath the coin, kind of flipping it over. If we were to move it this way, it would kind of flip over. And eventually, well, I guess this particular demonstration doesn't show it very well. But the idea would be if the coin was here, it would flip over and end up on the other side. Obviously, it wouldn't shrink, but it would kind of skew and scale over. So that's the idea that I want to work towards. And let's see. I guess the other diagram I wanted to kind of draw here was a side view. So if we imagine this is like the side view of what's happening, we'll have a coin laying flat like this. And let's see, if we draw a circle here, let's shrink this down a little. Then let's add another point, a line here, and the intersection here. Okay. So as the mouse comes in, if we were looking down from the top, we can again pull this up, and the coin would be on this segment here. We'd kind of flip it over the top. So I hope that makes sense. Guess this wasn't the greatest diagram to demonstrate it, but that's the idea. So I guess in order to model this, we're going to have an idea, a concept of a coin. It's going to have a location where one edge of it is, I guess, anchored to the surface, and then it'll have an angle that it's flipping over. And then I guess it'll also need a direction, or like an angle that the point that it's flipping over is tangent to on the surface. So let's define all that in our model. And I guess our model for the moment will just have a single coin in it. And we'll define coin as a separate thing. So that's going to have a location. I guess I'll call it the anchor, because this is going to be one point along the edge of the circle, which is going to be flipping over as we flip it. And actually I'm thinking now that maybe we should have two different types of coins, because they'll kind of behave in different ways. We'll have a coin that's flat on the surface, flat, and that'll have a center, which will be a float float. Let's give that a type alias called point. And then we'll also have a flipping coin, which is going to have an anchor point, and it'll also have an angle, which will be a float. Yeah, okay. I think this makes more sense, because if we have the coin flat on the surface, then it makes more sense to refer to it by its center point. And then when we start flipping it, depending on the angle that we come in at, we're going to need to calculate where the anchor point is. Like if we have our circle, and if the mouse comes from the right, we're going to be flipping over the left edge of the circle. But if it comes from the left, we're going to be flipping over the right edge of the circle. Okay, so I think it makes sense to have these separate. And let's see. I guess we're going to need two different angles. We need the flip angle of how much it's up in the air. And then we also need the orientation, which is also going to be an angle, which is which direction is it pointing. And I guess we also need a size for all of these, which can be the radius. This will be a float. Okay, so then we're going to have our initial model, which for now is going to have a single coin, and we'll start out with having a flat coin with a center at, let's see, I guess we're going to hard code the canvas dimensions for the moment, and maybe later we can look at having it actually adjust to the window size. So let's use our 750 by 500 window size that we've used in the past. So that'll be 375 by 250 will be the center. And the radius, let's make that like 25. Okay, so there's our initial coin. We will have a message type, which, let's see, what are we going to have for the message? I guess we're going to have the mouse move. And let's check the docs for the mouse package again. A mouse dot position. Okay, mouse move with a mouse dot position. So we'll need to import mouse. And then we're going to need our basic update function. Takes a message and a model and gives back a new model and a command. And if we get a mouse move, we will fill that in later. And then we also need our view function, which is going to take a model and give back our HTML. And again, for this, we'll just put a placeholder for the moment, html.text with the toString of our model. Okay. Then, what's the error we have here? Can't find the mouse module. Okay, we need to install that. Elm package install ElmLang mouse. And I forgot my equal sign there, and we didn't expose the HTML type. Guess let's expose the SVG type too while we're here. And then we need to fill in everything our program needs. So that needs an init, which will give back our initial model and no command. We're going to have our subscriptions, which is going to be no subscriptions for now. And our update function is defined above, and our view function is also defined above. Okay. And we need a type annotation for our initial model. And what else? SVG is undefined. Okay, we'll use that in a minute. Okay, so now let's start up Elm Reactor and load this up. And let me bump up the font size. Okay, so there's our initial model. Great. So now let's render this. So we're going to have an SVG canvas. It's going to have, let's see, we need to give it a width and height, as well as giving it a view box. So I think these are all in the html.attributes package, or excuse me, module. And the width then is going to be 750. The height is going to be 500. And the view box is going to match. It'll have the top left corner will be 0, 0, and the coordinate space that is inside of the SVG canvas will be 750 wide by 500 tall. And let's see, then that's old code. Okay, great. And then inside of that, we are going to have an SVG circle that is going to have a radius of whatever the model.coin.radius, and we'll toString that. And we also need the children list there. All right, let's see how that goes. Model.coin is type coin. Oh, we actually have to destructure this. Okay, so let's grab this. We will make a render coin function and pass model.coin. This is going to take a coin and give back an SVG. Okay, and we'll need some cases in here. So case coin of, and if this is a flat coin, then we will render this way using data.radius. And otherwise, we will fill this in later. Okay, so there's the tiny circle in the top left corner. So let's actually move it to the right position. We're going to svg.attributes.transform this. And we will build up a string, which will say translate. And we'll need to toString the data.center. And I guess maybe we should make a function. We'll call this a translate string. It'll take a point and give back a string. So this will be the x and y, and we'll use that to build up the string here. X plus plus toString of y. And then we can use that in here. We'll use the translate string of data.center. Okay. Great. So there's our circle. I guess we should maybe add a color to that. but I think I'm just going to hard code the color for the moment, and it would be pretty trivial to extract that to a parameter later. And let's see, what's a good color? Let's try that. A greenish yellow color? Not really what I wanted. How about an orangish color instead? Okay. There we go. Let's actually make this coin a bit larger for us to play around with. Okay. There we go. So let's see. I guess the next thing I'd like to do is, what should we do next? Should we try rendering the flipping coin, or should we try adding our interaction to actually make it flip? I am not quite sure. I guess let's try adding the interaction. And then once we have that hooked up, we'll do the rendering of the flipping coin, and then at that point we can kind of play around with it and see what we've messed up at that point. So we first need to subscribe to mouse messages. So we want to subscribe to the moves anywhere on the screen. So here in our subscriptions, we're going to subscribe to mouse.moves, and when we get one, we are going to generate our mouse move message, which we've defined up here. Okay. And now, I don't know if you can see in the bottom right corner of the preview, but the little event ticker for the history is increasing as I move the mouse, so that looks good. So now let's look at our update function and figure out what we're going to do with this X and Y position. So let's destructure it here in our case statement. And let's see. So how's this going to work? I guess what I'd like to do is... Actually, I'm not sure we even want the mouse events for the entire screen. All we really want are the mouse events for when the mouse is over the circle. And once we have that, then we will want to calculate the position in the circle. So let's see if that's going to be easier or if we want to do all that calculation ourselves. So looking in the SVG events package, we have on mouse all this stuff. On mouse over, we could use on mouse down, on mouse move, on mouse out. So potentially we could use that instead of checking for the mouse position everywhere on the screen. Before we decide on that for sure, let's try writing the function that we're going to need here. And I'm thinking maybe at this point we should start extracting a new package for our coin. Let's see, I'm going to put this function up here, and if we decide to pull it out, we can do that quickly in a minute. So we're going to need a function that's something like start flip. It's going to take a coin and give back a new coin. And I guess it also needs a coordinate. So that's one question, is if we use the on mouse over, we won't actually have the coordinate of where on the coin the mouse is. So that would be kind of problematic. We could probably get it if we used a custom event decoder and then dug into the JavaScript event and pulled out the coordinates of the mouse. I'm not sure that's going to be any easier than just using the coordinates we already have. So let's try this. So we're going to have start flip. We're going to have a point. And okay, so the way I want this to work is, so say this green circle is our coin. Let me delete some of this stuff on here. Okay, so if this green circle is our coin, the mouse is going to be at a certain position. So say the mouse is over here. We want to figure out which direction from the center the mouse is and start the flip from the opposite edge. So wherever our center is, whichever direction the mouse is in, the opposite side of the circle is where our anchor point is going to be. And then the angle is going to start increasing as we move the mouse closer to that point. So we have a point. So this is the mouse X and the mouse Y and the starting coin. Okay. Let's see. So we actually already have some destructuring to do. And I'm wondering if it's maybe ideal to not keep these in the same record, because we don't really want to be able to flip a coin that's already being flipped. So that's interesting, first of all. So we may have modeled things incorrectly. And actually, I'm just going to follow and see where this leads. So with coin having both options available in it, we don't want to allow flipping of coins that are not already flat. So this data type, this coin data type, is actually getting in our way from doing that, because we'd have to destructure the coin and then have a fallback of what to do if we try to flip an already flipping coin. So to avoid that, let's just pull these out into separate types. So we're going to have a type alias flat coin, which will equal this. And then we're going to have a new type alias called flipping coin, which will equal that. And now our start flip, we can model more accurately. It's going to take a flat coin and give a flipping coin back. And now we're actually forced to write some logic to implement this function. Okay, so we are going to calculate our anchor point in a minute. We were just talking about our algorithm for that. The radius we know already. That's going to be coin.radius. The orientation we're also going to have to calculate. So that is, so for instance, if our mouse is down here and then this red point is where we set our anchor point, then the orientation is going to be the angle from the anchor point to the center. Because there are many potential coins that are all anchored at the same red point. So we actually need to know which orientation the center lies in. So maybe we should rename this slightly and call it center direction. And we're going to calculate that also. It's just going to be actually based off the same vector that we're calculating for the direction of the mouse position. And then we're also going to need the flip angle. And let's just start that at some small amount. And we might have a better calculation to do for this later. Okay. And actually, yeah, why don't we bump this up a bit just for debugging purposes. We'll like flip it up to 45 degrees immediately. Okay, so let's figure out how to calculate our anchor point. So we know the center, and we're going to know the mouse position. Let's see. So if we draw a line from the mouse position to the center and all the way through to the other side of the circle, that is going to be where we want our anchor point to be. And what else? I guess that's it. Well, it looks like we're going to be doing quite a bit of work with vectors. So let's see if there's an Elm package that does 2D vectors. I know there's the Elm Linear Algebra package. Or it's been renamed, it's just called Linear Algebra now. Okay, and I knew that had a vector 3, but it looks like it also has a vector 2 type as well. And this has addition, subtraction, negation, scaling, dot product, normalizing, the normalized direction. That's great. Okay, cool. I think we're going to want this. So let's install this. And restart Elm Reactor. Okay. So actually, I think I'm going to change our point to just be a vec2. And let's import math.vector2, and let's just expose everything in it for the moment. Okay. So in this case, our anchor point is going to be, so we want to find the direction from the center to the mouse position. So let's change this. This will also be a vec2 mouse position. So we want to find the direction from the center to the mouse position, and then go in the opposite direction by the distance of the radius, and that'll be our anchor point. So first we're going to calculate direction. I think I saw that in here. Direction. Yep, great. From B to A. Okay, so we want to go to the mouse position from the old center. Then we want to negate that, point in the opposite direction, negate, then we want to multiply it by the radius. And is there a multiply in here? Ah, scale. We want to scale it by the radius. By coin.radius. And then we also want to, then we'll just have a vector that is essentially pointing from the center to the anchor point. So then we want to add the original center back to it. And then we'll add coin.center. Okay. And then the center direction, we essentially have already calculated. It's just the same direction from the mouse position to the coin center. And that lies on the same line. So the direction from the circle center to the mouse position is the same direction as from the anchor point to the center of the circle. Okay. So I think we may have successfully created this. Okay. So now we have a problem. We've changed our types. So this is just going to be a flat coin for the moment. Oops, which I spelled wrong. There we go. And okay, there's multiple functions called negate, so we need to specify which one this is. And then this is just a type alias now. And what else is wrong? Okay, so this is a flat coin, in which case we don't need any of that. And then data just becomes coin. And this, I guess, should also be called render flat coin. Okay, so that cleans that up. And what else do we got? Ah, okay. So I think the problem here is we need to make this a vector. Yep. And what else is wrong here? Ah, our center direction is now being represented as a vector rather than an angle. So I think that's fine. And then translate. Ah, this is taking a vector. So this is now toString of, let's stick this in here. So let's just rewrite this the other way. This is going to be x piped to get x, or it's going to be the vector. Let's just call it p. And then the same thing here, p piped to get y, piped to toString. Okay, so that compiles. Let's see how we did. Okay, so we have this new function that can now start a coin flipping. So now that we've split this coin type into two separate types, we're going to have to figure out how we're representing this in our model. And I think it might be time to just jump to a much more flexible representation. We'll just have the flat coins, which is going to be a list of all flat coins, and then we'll have the flipping coins, which will be a list of all the flipping coins. And we'll just go from there. So we'll start with no flipping coins and one flat coin. Then our view function. Now, instead of this, we are just going to render all of these. So we'll take model.flatCoins and map over each of those and call our render flat coin function on it. And then we'll have a list of items, so we'll stick those in a group, and that should do that. Okay, so now we can actually write our update function. So I guess what we want to do is, let's see, whenever we move the mouse, we want to find out Well, we want to take any of the existing coins, and if the mouse is over any of them, we want to call our start flip function to turn them into flipping coins. Okay, so here's what I think we can do. We can take our list, and I think there's a function called partition in the list package, which will let us give it a predicate, and I think it's near the bottom here. Sort with, sort by, index map, blah, 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 partition. Yeah, okay. So partition will take our list of flat coins, and my thought here is we'll write a function that determines if the mouse position is over the coin or not, and it'll return either true or false. And what partition does is it gives us back two lists. One list of all the items for which the predicate was true, and another list for which another list of all the items for which the predicate function returned false. And let's see. Yep, and it's in that order as well. Okay. So I think we're going to need a let block in here. And we will get the coins to flip and coins to keep. And we'll get that by calling list.partition. We're going to need a function that, let's see, contains mouse. And then we need our list of all the coins, or all the flat coins. And we'll also define contains mouse here, which in each case is going to take a coin. And we just want to return true or false of whether the coin contains this mouse position. And we should be able to just use the vector distance, the distance between two vectors. Great. So if we just convert the mouse position into a vector, we can calculate the distance between the center of the circle and the vector, and if it's less than the radius, then the mouse is in the circle. So we are just going to return distance from the vec2 of the mouse position to the coin.center, and if it is less than or equal to the coin.radius, then the mouse is contained in the coin. And we have to two-float both of these. Two-float x and two-float y. And then let's split the line here. Cool. And actually, let's pull this out to a separate thing. Mouse vector. And I guess let's just call it mouse position as well. Okay, so we create a vector for the mouse position, calculate the distance from the mouse to the center of the coin. If it's less than the radius, then the coin is under the mouse, and that means we're going to pull it out into this list of coins to flip, and we'll also get coins to keep. And with that, I think we are basically ready to finish up this function. So now what we'll return from our update function is our model, but we're going to change the flat coins list to only be the list of coins that are still flat, meaning the coins that were not touched by the mouse on this update. And then we're also going to create some flipping coins, and we're going to use the coins to flip, and that'll fail the type check, which I think this is another benefit. Yeah, I'm feeling more and more like this decision to make these two separate types rather than different options in a single type was the right decision, because we have actually some good type safety down here. So we're going to take all the coins to flip, and we will map over each of them and call the start flip function on them. And we also need to pass the mouse position to each of those. So start flip with a mouse position is a function that can change flat coins into flipping coins. Whoops, mouse position. Okay, great, and that type checks. So let's see, let's try this. I guess what we should see at the moment is when I move the mouse onto the coin, it's just going to disappear because we're not actually rendering the flipping coins at the moment. And it does. Okay, so at least some things here are working. So now let's render our flipping coins. And we'll do the same pattern here, render flipping coin, and then we'll put them all in a group. So we're going to need this function. It'll take a flipping coin and give a message. I feel like I'm trying to swear every time I say flipping coin. Or barely, like the mildest form of swearing I can imagine. Okay, so we have our coin here. We're basically going to have a circle. Let's color this slightly differently right now, just so we can see what's going on. So we'll make it kind of a brighter orange. And we don't, okay, so we're going to have to position it differently as well. Okay. So let's see. We can definitely find the center of the coin, but the center is going to be calculated by taking our anchor point and adding the center direction times the radius. And actually, let's see, how's this going to work? I think we're going to need to do our transformation in multiple steps. So first of all, we want to shift the circle over so that the anchor point is at the origin. And then we're going to kind of scale and skew the circle so it looks like it's kind of flipping up off the surface. And then we want to translate it to the position of the anchor point. Okay, so let's do a string.join and build up some different transformations in here. So the last thing we're going to want to do is translate to the anchor point. Or I might have the direction backwards. I always forget if the last thing needs to come first or last. I think it should come last, but I am often confused or forgetful about that. So let's see. The first thing we want to do is translate. So when we make this circle by default, it is located around the origin, so it's centered at 0, 0. We want to move it so that the anchor point is at 0, 0. So to do that, we're going to translate by coin.centerDirection, only the opposite of that. So we want to negate the center direction, and we also want to scale it by the coin.radius. And we want to use math.vector2.negate. And we need a comma in here. Okay, so that should handle the translation properly. So if I did that right, when I mouse over this, it should just turn orange and stay in the same place. Whoop, and I did not do it right. Let's see if we can inspect what's happening here in the debugger. So we had that, and at some point here, I'm just going to keep pressing down until we find it. Okay, there. Okay, so between whatever frame this is, 68 and 69. Okay, so we had our flat coin at center of 375, 250 with a radius of 40. And then in the next frame, we ended up with a flipping coin with an anchor point and a center direction and a radius of 40 and a flip angle. Okay, so that all looks okay, but it moved, and it looks like it flipped around the flipping point, or the anchor point. So I think I just have the negation incorrect. Let's try taking the negate out and see if that fixes it. Yeah, okay. I think that worked okay. So I saw it briefly flash orange, but we seem to have another problem in our update here. Oh yeah, so both the coins are gone out of the list now. Okay, so here we have our flat coin. Then, and I'm pressing up and down on the keyboard, by the way, to navigate between the messages. So here we have our flat coin. In our next frame, we have our flipping coin. And in the next frame, we have nothing. So I think our update function is messed up. In that, let's see, when we have a mouse move, right, okay, so in this case, the coins to keep was empty, and we had no new coins to flip. So yeah, whenever we flip new coins, we want to also add it to the old flipping coins. Okay, so we were just throwing away all the old coins every time. Let's see, is it called append? List.append? Yes, okay, great. There we go. Okay, cool. So we turn it into a flipping coin, and it changes colors. So our last step here for rendering this is we need to apply the transformation, which is our flipping angle. And let's see, so how do we want to do this? So if we're looking from the side of this again, the coin itself is going to be on this line segment. And my thought is we just want to kind of squish, since we're looking from the top down, we want to squish the width, or like one dimension of the coin, based on the length that we would see it occupy from the top. So the radius of the coin, actually this is the diameter here. The diameter of the coin is this segment, and we want to figure out how long it is from the top. So let's see. So the length here is going to be the cosine of the flipping angle, and I guess then we just multiply by the radius. So I think that should be right. And that means, let's see, so we want to be scaling this we shouldn't need to include the radius because that's already accounted for when we draw it. So I think maybe we can just scale down in one direction by the cosine of whatever the flipping angle is. So let's try this out. And my thought here was, first we're going to translate so the anchor point is centered, then we're going to scale it against the anchor point, and we're also going to need to use the orientation to correctly orient this, but we'll deal with that in just a minute. So we want to scale by, let's say the y amount will always be 0, and the x amount is going to be cosine of the coin dot flipping angle. Did I remember that right? Flip angle. Okay. And what's wrong here? Oh, we need to two-string this. Okay. Let's see if this works. So remember, we're also hard-coding the angle to be 45 degrees. Okay. So that totally did not work. Let's see. The flip angle should be stored in radians, taking the cosine of 0.785. We have to use parentheses here, is 0.707. So we should be scaling by 0.707. Okay, and that might be working correctly, but I'm going to guess that I just have the order of the transformations backwards. So let me try flipping these real quick and see if that solves the problem. No, it does not. Okay, then let's debug this a little bit more. And let's see, I'm going to pull this up here so we can see it a bit better. And I'm also going to pull up the debugger to pause what's going on. Okay, so let's look at the DOM structure that we're creating. So we do have a circle, and it is being scaled. Oh, right, I'm scaling the y by 0. We need to scale the y by 1. Okay. That, I think, was the problem. So let's scale the y by 1 instead of 0. And refresh this, and great. Okay, so that flips up. The problem is, it doesn't flip up in the correct direction. So if I come from the bottom, it needs to flip in the right direction. So, and interestingly, okay, let me try flipping the order of these transformations back again. Yeah, okay, so we do need them to, like, I don't know, this always feels backwards to me, but the first thing we're doing is anchoring it, or moving the anchor point to be at 0, 0. Then we're scaling it. Then we are translating it to its final position. Okay, so what we want to do here now is, before we scale it, we want to rotate it so that the direction we're scaling in is going to be in the x direction. And then we'll rotate it back after we scale it. So we're going to rotate by some amount. Which is going to come from the orientation, which I forget if we stored that. We're storing that as center direction. So we need to get the angle of the center direction. And I'm not quite sure of the signs. I think I'm just going to try doing this with trial and error to get this right. Let's see, is there a way to convert a vector to an angle? Direction, length. Oh, interesting. I would have expected there to be a function to do that, but I guess we can just use the core package and use the arctan function. And since we have both the x and y, we want to use arctan2 so that it can actually work for all values. Cool. And Boomerang just mentioned that in the chat. You almost beat me to it. Or I'm sure he beat me to it for everyone else who's on the chat delay. Let's see, and I guess it's saying that we need to pass the y first. That's kind of interesting, but Boomerang agrees, so we will do that. And also, we learned the other day that rotate in SVG requires the parameters to be passed as degrees. So we have to convert the radians to degrees, which kind of sucks. Okay, so we want arctan2 of the y position. So that's the get y from coin.center. And actually, I'm going to pull this out and call this a rotate string. And we'll define this up here. Rotate string takes a vector 2 and gives back a string. Okay. And in here, we're going to get the y of the point, and we'll get the x of the point. And then we get all that, and we need to convert it into degrees. So that means we divide by pi and multiply by 180. Okay. And then here we are passing rotate string for the coin.center direction. And then here we are going to rotate the opposite way. Huh, interesting. We actually need to go the opposite angle, which we can't easily get by, like, we can't just negate this, can we? I don't think we can. Let's see, Boomerang's asking, earlier it looks like the scaling was done on the left side of the coin. Is the anchor point in the center? No, so I think the anchor point is getting calculated correctly. When we start a flip, we calculate the anchor point to be the point on the far side of the coin from wherever the mouse position is. So that's different depending on where the mouse is when you touch the coin. Okay, so I'm realizing this helper function is not particularly useful, but we can pass the angle here and do some of the string manipulation. And then here we can calculate the rotate angle. As that, and here we will rotate, I think we want to do the positive one first, which means it comes last in the list, confusingly. And then we will do the opposite rotation after we scale it. And P in this case is coin.center direction. Okay. Let's try it out. And did I spell angle wrong in here? Oh, this is a float now. And what is wrong with this? Oh, I need to two-string this. Okay. So, if my mouse comes from the right side, it shrinks up to the left. And if it comes from the bottom, it shrinks up towards the top. And if I come from the bottom left, okay, so that's wrong. We've got things kind of mirrored, I guess. It is close to working. Interesting. Okay, let's try just flipping these. I don't think this is going to be the answer. So that one works. That one works. Oh, it is. Okay. Great. So whichever direction my mouse comes from, it starts flipping. Great. Okay. I am happy with that. So I think our next step, let me move that back to the preview window. Our next step then is going to make the flips change, what we want next is to have the mouse actually influence or be able to interact with the flipping coins, so we can push them all the way over as we move the mouse. So I think it's time for a short break. So let's take just a couple minutes, and when we come back, we will be making the mouse interact with the flipping coins as they flip. So I will see you back in just a minute.